Temperature. Temperature is related to heat, but they're not exactly the same thing. Atoms and molecules are in constant random motion, just like all of you guys. You're all moving. My son Andrew is 7. He has figured out that if you move constantly, you will not fall asleep. Even if you've done what Mom said and you stayed in your bed, it's been starting at 9 o'clock, here it is at 11 o'clock. There's no books or toys or lights or anything, he's still awake. Because every time you peek in, he's in a different position. Just never stops moving, right? We don't ever really stop moving, even when we're sleeping, right? We're still breathing, hopefully. The particles of matter never stop moving either. The particles in this desk are moving. They're wiggling back and forth. When you heat something up, you cause the particles to move faster. So if I were to raise the temperature of my analogy here of students in the solid state, that would be like you guys chair dancing, right? Jumping up and down, you're just like all antsy. Somebody has to go to the bathroom, doing a little potty dance in your chair, right? You know, this just antsiness, moving faster. You can take a solid, and when you increase its temperature, the particles are moving faster, but they're still relative to each other in the same place. Eventually, they move fast enough and they'll break apart, and then you're going to get the liquid. The hotter an object is, the greater the random motion of its particles. So temperature is a measure of the thermal kinetic energy of the particles. Another way to think about this is think about barefoot people on a beach. I live in Reedley. It's very popular for people to go to Reedley Beach in the summer. Did you know there was a beach in Reedley? Big sandy beach on the river, right? But that sand gets hot, right? Do you just stroll casually from the parking lot to the river barefoot in July when it's 106? No, because that sand will burn your feet. How do you get there if you don't have flip-flops? You run. You hot-foot it, right? Ah! What if you go to Pismo in July, where it's like 65 degrees, overcast, and there's gale force winds coming off the ocean, and you're freezing? Do you have to run to the ocean there in your bare feet? No, because the sand is cool. Cooler temperatures, slower, less motion. Hot temperatures, more motion. So temperature is average kinetic energy of the particles in a substance. Heat is the transfer or exchange of thermal energy. It's energy moving from one substance to another. And this has units of energy. If we take a piece of cold ice and put it in a cup of warm water, what happens? The ice melts. It warms up and it melts, and what happens to the temperature of the water? It cools down. There is a flow of thermal energy, there's a flow of heat from the warm water to the colder ice cube. And that flow will continue until the temperatures of those two things are equal. If you put a hot soda and a block of ice in a small cooler together, and you wait till dinner, they're going to be the same temperature. If you put a bottle of water and a bottle of soda and you wait until dinner, you're not going to have one be warm and one be cold. It just doesn't work that way. It always flows from higher temperature to lower temperature. So heat is the transfer of energy, and temperature is a measure of the thermal energy. We'll talk about temperature scales on Thursday.